values, and organizing it into a clean and usable format. Okay. What I say, data pre-processing is the process of preparing raw data by fixing errors, handling missing values, and organizing it into a clean and usable format. Just like washing and cutting and organizing vegetables before cooking a meal. If I say and a real life example, you were filling out a college admission form, okay? And now, if you leave your age blank or type your name in all capitals letters, or leaving your um, phone number blank, age blank, DOB blank, then the staff will first correct and complete your form before processing it. That's exactly what pre-processing and cleaning does to data. Suppose you run a school and maintain student records. So one student has written their name as Rahul, R in capital, and another as Rahul, R in small letter, and third left the age column blank. So before you generate the final report cards, you will first standardize the names, fill the missing values, missing ages, and remove any duplicate entries. So that the whole process fixing such issues, it is data pre-processing and cleaning. Okay. So before we clean the data, we must know what kind of data we are dealing with. Um, So first we should know what is data. Okay. So data is simply a collection of raw facts and figures without any context or meaning. What I'm saying, data is simply a collection of raw facts and figures without any context or meaning. But when processed, it becomes information. First, any kind of raw facts or figures, any information, it will be a data. And after processing it, it will be a information. Okay. Um, so when you enter your name or marks or phone number in a form, what are you actually providing? This data, right? So if I take an example, a list of numbers like 90, 70, 85, these are marks. These are also a data. We can call these marks as a data. Okay. So now there are different types of data, like numeric data, categorical data, static data, dynamic data. The numeric data means numbers. These are whole or decimal numbers. Okay. For example, age and GPL, and you can say marks. These are numeric data. And categorical data means categories or labels like gender, male, female. These are categorical data. And then text data, like review, good product or not. This will be text data. And multimedia like images, audio, video, etc. Suppose you have a YouTube video. It's not just a video. It's a mix of sound, images, motions, and all of that is data. Okay. There are some other kinds of data also, like distributed data, text data, web metadata, images, audio, video. These are also some data. And distributed data means these are stored in different locations, like cloud and the local server. It will be stored in different locations. Okay. And web data, these are means collected from websites like likes, comments, etc. And metadata means data about other data. Metadata are data about other data, like photos, a resolution, date taken, size. These are metadata. Okay. And One more thing is there. It was static and dynamic data. So what is static data? So static data are does not change frequently, like your date of birth or blood group. But dynamic data, these are changes with time, like temperature, then heart rate monitor data. These are dynamic data. Okay, so what I say, data is raw fact. It can be numbers, text, images, or even video. And it can be static or dynamic. That means static means does not change over time, and the dynamic means changes over time, and it plays a key role in everything from your phones to your Netflix suggestion. Okay, I say it now, right now, like nominal data value of nominal attribute are just different names. Ordinal, these are ordinal attribute like hardness of minerals, good, better, based, and then interval data, residual data. Interval means calendar dates, temperatures. Okay. So now, why data pre-processing? See, in real world, data is not always beautiful and perfect like textbook problem. Okay, so if I give an example, like you are about to bake a cake, okay, and you have all the ingredients like sugar, milk, eggs, all are these are available. But if the sugar has ants and the eggs are broken, will your cake come out well if you just throw it on the oven? Of course not. So first what we will do, we have to clean, fix and prepare everything before you start baking. Okay, that's exactly what we do with raw data. In the real world, data does not come to us in a clean or ready to use form. Okay, the data may be incomplete, noisy, inconsistent. So incomplete means it will missing attribute values, lack of certain attributes of interest. Like here, the occupation is blank, so it is incomplete. It is missing at value. And noisy means containing errors. That is salary. Can salary be -10? Obviously no. So it is noisy data. So, if a student forget to write their phone number in the admission form, that will be missing data. So, what is missing? If a student forget to write their phone number in the admission form, that will be missing data. Okay, and like twice with two different spelling, that will be duplicate data. And, um, and uh, if a sensor record it like a daily normal temperature, it. Okay, so why we do pre-process? Why do we pre-process our data? So we pre-process our data to remove mistakes, to fill in the missing details, to make data consistent, to make to get a better result. Okay, like checking exam papers for wrong entries, like, and to fill in the missing details, and these things are very important. Okay, because if we clean the data, then that only we get the smart result out. Okay, so if we don't clean our data properly, we are literally asking our machine to learn from garbage, and then we wonder why it's making wrong predictions. Okay. So the next is the importance of data pre-processing. Why is data processing is important? It's no quality data, the no quality result. Okay. So If your dataset has duplicate students or missing fees information and you run analysis on it, your entire report card system will show wrong result. Okay. So first it is very important to data pre-processing to clean our data to get a better result. Okay. Sometimes 90% of our time is spent just cleaning and preparing and organizing the data. Because modeling is the easiest part, but preparation is the very hard part. It takes most of the time in data preparation and cleaning the process. Okay. So there are some major tasks in data pre-processing. There are some major tasks. These are like data cleaning, data integration, data transformation, data reduction, and data discretization. So what does it mean by data cleaning? Data cleaning means we remove errors or fix missing values or get rid of duplicates. Okay, like washing our veggies. And the next is come to data integration. The data integration means merge multiple sources, integrations of multiple databases or files. We combine data from different sources into one clean table, like merging different tables into a single table. Okay. And the third one is data transformations. Data transformation means normalizing and standardize the data. And the fourth one is data reduction. That is, we remove unnecessary parts and keep only what matters. Data reduction means we remove the unnecessary parts and keep only the good ones. Okay. And the fifth one is data discretization. That means convert numbers into categories. Data discretization means convert numbers into categories. Okay. Like like grading marks like 90 plus percentage are converting to grade A, 70 plus marks are converting into grade B. These are discretization. Converting numbers into categories are what? Data discretization. So now we come to data cleaning. So cleaning, it is the biggest challenge in machine learning. If you ignore it, then obviously the model won't get us better result. It's not it. So data cleaning task, it will fill in missing values and then detect and fixed outliers and resolve inconsistent formats or remove duplicate values. Okay. Like if we have an informations of employee, like employee name is John, his age is null, and his salary is minus 25,000. Okay, so it is now it is the salary is minus 25,000. So it is noisy data. So now we have to clean it. So why we need to clean? Because we need to clean to correct these errors. Okay. Otherwise, it does make any sense that his salary is minus 25,000. Obviously not. So the real data is very messy. So sometimes the names are misspelled or fields are left empty, records are copied twice, or duplicate values will be there. So in cleaning, we fill in missing values, correct errors like his salary, remove duplicates values, and make formats consistent. Okay. So now it comes to missing data. So what is missing data? So missing data means that some values in your data set are blank, okay, empty or not recorded at all. So suppose you forgot to fill your address in an online form, so that is missing data. So in real life example, yeah, in a student form, if the student uh, will not fill his email ID, or in a weather sensor, like temperature value did not get recorded. So, or in a medical report, the blood pressure is missing for 1%. So these are some missing value. So why this is happen? So missing data may happen due to equipment malfunctions, like the machine did not capture the data, or human error, like someone forgot to type the value. So inconsistent with other recorded data and thus deleted, or not considered as important, like skipping optional fields. So missing data may due to these things like equipment malfunctions, data not entered due to misunderstanding, or certain data may not be considered important at the time of entry. Okay. So it is very important to handle missing data. Okay. So how can we deal with this missing data? There are some simple ways to handle missing data. Like first, we ignore the missing row if it is if like skipping incomplete forms, but it is not both. If the data set is large and if we miss all the rows, then it may um, get like missing information, important information. And then the second one is like fill it manually. If the data set is small, then you can manually fill in the blanks. Okay. And then we can fill with global constant, with a constant like unknown word, that is a constant, like put unknown for missing names. If someone name is missing, then we can put his name unknown, like, or in some, if some number is missing, then we can give some constant value. And then it comes with the attribute means, then fill with mean, median, or mode. For example, we have a age of persons, like age A. For A, we have age like 20, and for B it was missing, and for 3 it is like 22. So now how can we add this age for person B? So here we will do what average is. We'll find the average of 20 and 22. Then what we will get the value that will put for the missing age. Okay. And then predict the value using a model. So these are some algorithm like Bayesian formula decision tree. This things will you understand in your upper semester. It is not much important for now. Okay. So the next is noisy data. So what is noisy data? Noisy means random errors in your data. That is, I already said, like someone's salary will be in minus value. So it is random errors in the data. It could be due to faulty sensors, transitions problems, or human mistake, or technology limitations. Okay. So noisy data means what? The data that has errors, outliers, or unusual values that don't make sense. What I say, noisy data means that has errors, outliers, or unusual value that don't make any sense. Okay. For and then if I take a real life example, like a person's age is entered as minus 15, obviously it is not possible. So it is a noisy data. Then a student's marks are like 110 out of 100. So obviously it is also a noisy data. And the sensor recorded like 700 degrees Celsius temperatures on a normal day. So obviously it is also a noisy data. That means this data does not make any sense. Okay, so these are called outliers or noise, and they can completely confuse our machine learning model. If we don't clean this noisy data, then they can completely confuse our machine learning model. So here are some other data problems which require in data cleaning, like duplicate records, incomplete data, inconsistent data. These are some data problems. Okay. So now how to handle noisy data? So to handle noisy data, we have some methods like binding method, then clustering or combined computer or human inspections. So binding means what? Grouping similar values and smooth them. And the clustering means remove outliers by finding patterns. So what is binding method? Binding is a technique where we divide the data into small groups and then smooth the data inside each bin by replacing the value with the bin's mean, median, or boundaries. What I say, binding is a technique where we divide the data into small groups, small bins, okay? And then smooth those data inside each bin by replacing the values with the bin's median, mean, or boundaries. Like, think like organizing your messy pencils into three boxes. In one is short pencils, then medium pencils, and the long pencils. Okay, that inside each box you clean them up and align them properly. Like okay, I'm taking one more example. Let's say we have marks. Okay, we have 4 marks. Like one is 47, then 45, then 49, then 100. So here 100 is a suspicious since others are under 50 house, 45, 47, 49, and one is 100. So it is a suspicious value. So maybe it's a mistake. So here we can apply a binding method. So first what we will do, first sort the data and partition into bins. That means first we have to sort the data like 45, 47, 49, and then 100. It will be the first step. And the in next step, we will divide into groups. Okay, we'll divide into groups, or you can say beans. In group one, we will take the first two value, like what I say, 45 and 47. Okay, in group one we will add 45 and 47, and in group two we will add 49 and the 100. Now, in the third step, we will take the mean and the average value for of group 1 and for group 2. In group 1, we will take the average of 45 and 47. So, what will be the output? It will like 45 46. Okay, so now we will group them in group 1, or you can say in bin 1 we will add the mean value that we got, that is 46 and 46, and in group 2 we will take the average of 49 and 100. So in that will be the average of 49 and 100. It will be the result like 73 or 74. Okay, 74 point something. So, in group 2, we will take the average of 49 and 100, that is 74, 74. So now, since 100 was suspicious, it may be a mistake. So now the result will the marks will look like 46, 46, and 74, 74. So there is no outliers or no any suspicious data. Okay, so we smoothed out the data. Now that crazy 100 won't confuse our model anymore. Okay, So we can also smooth by using median or boundary value. Boundary value means replace which nearest mean, nearest bin mean or maximum value. Okay. So now second one is clustering. So what is clustering? Clustering is grouping smaller data points. Sorry. Uh, Clustering. So clustering is like grouping the same data points together, like similar data points together. And if a value does not belong to any group, so it will be considered as an outlier or noise. So what I say, clustering means combining similar data points together. Clustering means what? Combining similar data points together. Okay, imagine if you have grouped students by their height, okay, so most are around 5 to 6 feet, and one person is 9 feet tall. Okay, so this in here we will cluster of 5 to 6 feet students in one cluster, and the 9 feet tall boy will be considered as a outlier. Okay, so clustering is like what? Forming friends group. If someone is standing all alone in the playground and does not fit with any group, they probably don't belong there. That means, and they probably don't belong to their data set. Okay. So, okay, so there are some clustering algorithms like K means clustering, hierarchical clustering. These are also some advanced level algorithm you may learn in your upper semester. And now we are come to combined computer or human inspection. Okay, so sometimes humans look at the data and correct it. When, especially when the data set is small. So, you are checking your friend's assignment and telling them that he wrote his age as 400. So it can be corrected by human, right? So when do we do manual check? When the data set is small, or when you can easily spot errors, or when you don't trust automated methods. Okay, so when do we do manual check? When the data set is very small, or you can easily spot errors, or when you don't trust automated methods. Okay. Like one more example is like employee information, like name is like XYZ, his name is Rahul, then age is 27, and then his phone number is given 9101 something, and salary is again this minus 45,000. So yes, we can check manually and fix it. We know that minus, say minus value does not make any sense, so we can correct it to it 45,000. So these are manual or human inspection. Okay, so now come to data integration part. Data integration means combining data from multiple sources into a single consistent and clean format. Okay. What is data integration? Data integration is the process of combining data from multiple sources into a single, consistent, and clean format. Okay, remember, uh, combining data from multiple sources into a single, consistent, and clean format. Uh, if imagine you have one Excel sheet with students' names and ID, and another sheets with IDs and marks. So we can combine both of them, right? To make on a single table, like where it will be student names, IDs, and marks. So that is data integration. So why do we need it? Why we need data integration? So in real life, data is stored in different places. So we want to bring them together to get the complete picture. So it will helpful if we combine all the data together and to get it in a complete picture. Okay. So, but there are some problems in integrations like schema integrations, integrated metadata from different sources, then detecting and resolving data value conflicts and removing duplicates like schema mismatch, columns name differ, then it will create problem. And unit inconsistency, like in some cases it is like a different scales matrix, like in some cases it is in centimeter, or in some table it is like inches, so it may create problem. And the next one is duplicate or conflicting records. So that's where we need to clean and standardize our data before combining. So before combining, before integrating, we need to clean out and standardize our data. Otherwise, we will end up with double entries or some wrong information. Okay. So now the next one is handling redundancy in data integration. Redundancy means duplication. Redundancy means duplicate value. Okay, redundancy means what? Redundancy means duplicate value, the repeated value. Say if you successfully integrated data, or you successfully combining data, but suddenly you realize that yes, some information is repeated or not even needed. So that's called redundant data, duplicate data. Okay, repeated data. Redundant data occur when integrations of multiple databases, object identifications, or derivable data, and these things happens in data redundancy. So redundancy happens when the same data appears more than once or is derived from something else, and does not need to be stored again. For example, like in table A, mm, um, some ID and monthly salary is there in table A, customers ID and salary. So ID is let's say 1 and salary is 20,000. And in table B again ID is 1 but salary is 20,000 into 12, 2 lakh 40,000. Okay. So this is redundancy. That means, so do we really need both? And in table one, it is monthly based salary, and in table two, it is yearly based salary. So we don't need it, right? We can calculate it from the monthly based salary. So that is redundant data. So there are some redundancy problem, like same thing, different name, employee ID versus employee number. This is the same thing, but different name. So it may occur problems. And derived data like yearly salary calculated from monthly salary, and duplicate data like same students entered in two system with different spelling. So how to fix it? To fix this redundancy, we can use correlation analysis and covariance analysis. This is the redundant attributes may be able to be detected by correlation analysis and covariance analysis. Okay, correlation analysis means um, check if two columns give similar result, and covariance analysis means check how two attributes change together. What? Correlation means correlated. correlated. The two columns give similar result. That means the two columns are correlated. And covariance analysis means check how two attributes change together. Okay. So we can use these tools to find unnecessary data and remove it, so we don't overload our database and confuse our machine learning models. So this is correlation analysis. It was a chi-square test. It is correlation. Chi-square test is correlation analysis. So we use chi-square test to uh, check a relationship between categorical variable. Okay. Chi-square test, where we use chi-square test to check relationship between categorical variables. Like it is a statistical method. Chi-square test is a statistical method used to check if two variables are related to each other or not. Okay, chi-square is a statistical method used to check if two variables are related to each other. And if the larger the chi-square value, it is more likely the variables are related. Okay, larger the chi-square value means the variables are correlated. Okay. So yes, this is an mathematical example. Here, like here we are talking about categorical data. Okay, so like someone's play some play chess and some play not, and like Chinese, some students like Chinese science fictions and some may not like science fiction. So here we will find a regular correlation formula, and we use chi-square. So it checks whether there is relationship between two categorical variables. Let's say you want to find if students who like science fictions also tend to play chess, or it's but or who some like does not like science fiction but want to play chess. Okay, so these are some mathematical sums calculations. Okay. Here, some to use chi-square formula. In this is chi-square formula. Actually, I did not give the exact formula. Okay, so we have to do observed value, then minus expected value, and divided by expected. So here 250 is observed value and 90 is expected value, and so this is the formula of observed value minus expected value whole square divided by expected value. By doing this, we can calculate the chi-square value. And if chi-square value is there will be degrees of freedom. If degrees of freedom is like rows minus rows minus 1 into column minus 1, it will be the degree of freedom value is 1. If the chi-square value is greater than 1, that means liking science fiction is significantly related to playing chess. Okay. So, chi-square test tells you if two categories are related or not. It does this by comparing what you expected with what you actually observed. So it tells us if two categories are related or not, or it does by comparing what we expected with what we actually observed. Okay. So the next is data transformation. Data transformation means changing our data from one format to another so that it becomes more useful and meaningful for machine or machine friendly. Okay. So data transformation means what? Data transformation means changing our data from one format to another so that it becomes more useful, meaningful, and machine friendly. All right. So, it means changing our data from one format to another so that it becomes more useful, meaningful, and like why do we need transform data? Why do we transform our data? We need to remove noise. Okay, so unwanted or random errors will be there in the data. So it can be like spelling mistakes or outliers value. So we have to remove it and to scale data into similar range. Like different features in our data set may have different units or ranges. Like salary 40,000, age 21. So the algorithm might give too much importance to salary because it's a big number. So here we have to normalize the data because since salary is a big value and age is a small value, so the algorithm might give too much of importance to salary. So here we have to normalize or standardize our values to bring them to the same scale, like 0 to 1. Okay, we will normalize the values to 0 to 1. So all features are equally treated by the model. Okay, the next one is to combine columns to combine columns, like sometimes two or more columns can be combined to give a new insight. Like you have math marks, physics marks, or chemistry marks. So combine them to make a new column, that is total mark. Okay, so combining features helps reduce complexity and gives the model a new or more useful features to work with. Okay, and the attribute or feature constructions, the new attribute constructed from the given ones. This is, and to create new features, new columns can be made from existing data to highlight patterns and to make data easier or to understand. Okay, understand or analyze. Sometimes the raw data is too complex or detailed or hard to interpret, so we simplify or generalize it. Okay, so this make it easier to group users, analyze trends, and visualize results, especially for dashboards or summary reports. So, what is data transformation? Data transformation is like prepping our ingredients before cooking. Okay. With transformation, your data may be too messy. Without transformation, your data may be too messy or too scattered or too boring for a model to make anything useful out of it. So we need to transform it. We need to standardize so that every value of the data may take same priority. Okay. So data transformation, there are some data transformation technique like normalizations technique. It means normalization technique. It's a min max normalization, z-score normalizations, and these are some normalization technique. It means adjusting all values in a column so that they are within a similar scale. Okay. So this min max normalization technique, we take minimum or maximum normalization value. Then these are some mathematical formula like z-score normalizations and normalization by decimal scaling. Okay, these are some normalization technique. And next is data reduction strategy. Data reduction means reduce the size of data without losing any important information. Okay. So what is data reduction? Data reduction means reducing the size of our data set without losing important information. Imagine you are studying for an exam, and you don't read the whole book, right? You use some notes, summaries, or some important topics only. So that is data reduction. Reduce the data. So why we will reduce? We will reduce to saves time or memory, or makes model faster, or help visualize better, or avoids overfitting. Okay. Mm, because we have to reduce, because sometimes it may have less memory, so we have to save our time and memory and make model faster. So we have to reduce our data sets, and all the data in a data sets are not important. So it is necessary to reduce the data set with meaningful information. Okay, reduce data reduction does not means that you are reducing your data and you are losing your important information. It is reducing the size of your data set without losing important information. Okay, there are some data reduction technique, like dimensionality reduction technique, like principal component analysis, or feature subset selections, or feature creation. And then numerosity reduction, like clustering, sampling, and data aggregations, or data compression. PCA, what is PCA? These are some advanced level methods. This is not very important for right now. You will teach these things in your upper sem. And the next one was clustering. I have already said, and the sampling, data aggregation, and compression. Data aggregation means summarize the data. Okay, data aggregation means summarize the data, like turning daily sales into monthly. Or compression means compress the data to take less storage space. So we'll come to these things. Uh, sorry. Dimensionality reduction. So, curse of dimensionality. What is curse of dimensionality? Curse of dimensionality means as features increases, the data becomes sparse. This is called curse of dimensionality. Okay, like curse of dimensionality means more features, more complexity, and more confusion. If in simply terms, what is curse of dimensionality? If you will ask, then it will be like, if we have more features, then it will have more complexity, and more complexity means more confusion. That is called curse of dimensionality. Okay. So dimensionality reduction is the process of reducing the number of features or columns in your dataset while keeping as much useful information as possible. What is dimensionality reduction? Dimensionality reduction is the process of reducing the number of features or columns in your dataset while keeping as much useful information as possible. Like imagine you are designing a model to predict house price, and you have 100 different features. Okay, you are designing a model to predict house price, and you have 100 different features, like number of rooms, size of house, type of flooring, wall color, owner's blood group, then fan speed. These are some features. Okay, but from these features, type of flooring, wall color, owner's blood group, fan speed, these are unnecessary data. So not all the features are important. So some are just noise, like fan speed, owner's blood group, wall color, these are noise. And some are correlated, like number of rooms, size of house, these are. Okay, so we want to keep only what's necessary. Okay, this is, and the others we will discard it. So this is dimensionality reduction. Okay, so why we reduce dimension? Because we are uh, because means for getting rid of curse of dimensionality, like where we have more features, like more complexity, more confusion. So we have to reduce the dimensions, or we have to reduce the unnecessary information from our dataset. Okay, so let's say one more example is you are studying for your exam, okay, and you have 10 books for one subject. Will you read all the 10 from start to finish? No. You will look for like short notes, most important chapters, and teachers' highlights. So that's what we do in dimension reductions. We keep only what matters. Okay. So there are some benefits of dimensionality reductions. By using dimensionality reduction technique, we can speed up our model, reduce memory uses, makes visualization easier, and reduce overfitting. Overfitting means when model does not learn unnecessary stuff. Okay. Here are some dimensionality reduction technique. Again, PCI is a dimensionality reduction technique. Then supervised and unsupervised feature selections method. Okay. So these are some dimension reductions techniques. So now we will come to the part what is feature selection. Okay. And feature selection in our previous slide, what we talked about dimensional reduction, where we reduce the number of columns or to simplify our data and speed up analysis. So, feature selection is the process of choosing only the most important features from your entire data set that are actually useful for your model or analysis. Okay, the feature selection is a process that chooses an optimal subset of features according to a certain criteria. Okay, what I say, it is the process of choosing only the most important features from your data set that are actually useful for your model analysis. Real life example, like you are making your resume. So you are adding some features like your name, your email, your marks. Okay, so these are important features. You have to add these features. But your favorite Netflix show or the last movie you watched, these are not important. So these things we will deselect these things. Okay, so this will be we will be discarded from our features. So here it is the choosing only the most important features for a resume. So what features you will take? Only your name, your email, or your marks. These features you will take. Okay. So why do we need feature selections? Why do we need feature selections? We need feature selections to improve model performance, to improve accuracy, model performance, model accuracy, okay, to improve the model simpler and to avoid overfitting. Overfitting means like overfitting is like a student who memorizes every single word from the textbook, okay, even the spelling mistakes. But when asked a slightly different question in the exam, they get confused. Means overfitting means when a machine learning model learns the training data too well, including all its noise, errors, and random patterns, so much so that it performs poorly or on new or unseen data. What I'm saying, overfitting happens when a machine learning model learns the training data too well, including all its noise, errors, random patterns. It learns too well so that it performs poorly on new or unseen data. Okay. So we use feature selections to reduce dimensionality or remove noise to make visualization easier. Okay, so what I say, why we need feature selections? We need feature selections to improve our model performance in case of speed or predictive power or simplicity of the model, to make the model to improve model accuracy, to reduce training time, or to make visualization easier. Okay, so let's say you are predicting students' performance. You have some columns like age, attendance, test scores, and favorite colors. So here, to predicting students' performance, age, attendance, test scores is important features. But favorite color is not useful, so we can remove it. This is a feature selection, selecting the most important features. Okay. So good features means good model. So too many useless features does not mean it will be a good model. Too many useless features, it will give bad performance. Okay. So less features but good model. Okay. So next is clustering. Clustering means grouping similar data. I already said it. Clustering means grouping similar data. You partition the data set into clusters and one can store cluster representation only. It can be very effective if data is clustered, but not if the data is smart. Okay, there are many choices of clustering definitions and clustering algorithms. So clustering is a technique that groups similar data points together based on patterns without knowing the actual categories in advance. Okay. What is clustering? Clustering means grouping similar data points together based on patterns. Grouping similar data points. Okay. So imagine you walk into a classroom with student informations, and you observe some are talking about coding, and some are painting, some are playing football. So now you have to make clusters. Okay. So what will you do? You will make three cluster, like grouping three groups. One for coders who are talking about coding, then artists who loves painting, and then athletes who playing football. So that's clustering. Clustering means uh, grouping them into a cluster by their choices or based on their patterns. Okay, based on their behavior, or even we don't know who was who. So that means it's we are grouping similar data without knowing the actual categories in advance. Okay, so why is clustering important? Why clustering important? It helps explore data when labels are unknown. It helps explore data when labels are unknown, and it is useful for market segmentation, anomaly detection, recommendation systems. It is also used in data reduction, store only cluster representative. Okay. So it's actually clustering is an unsupervised machine learning algorithm. Unsupervised machine learning algorithm means there is no labeling. Okay, we don't know what is the labeling. We don't know what is their name or these things. So next is sampling. Sampling means obtaining a small sample to represent the whole data set. It means taking a small portion of the data to understand or analyze the whole data set. What is sampling? Sampling in data means taking a small portion of the data to understand or analyze the whole data set. Okay. Sam, it is the process of selecting a small representative portion of a large data set so that we can analyze or model it without using the entire data. Sampling means obtaining a or taking a small sample from a whole data set. Why do we use sampling? We use sampling when the data set are huge or processing full data takes a lot of time and memory. So we take a sample that reflects the whole data set. Okay, it's like doing a survey. Okay, you don't ask every single person in India whom they will vote for. You just ask a selected group and draw a conclusion. Okay, so if we take a real life example, like feedback. So you sell 10,000 mobiles, okay, and you want to take feedback from you will take feedback from 1,000 customers. If 900 liked it, that you can estimate overall satisfaction, isn't it? But you didn't take the whole 10,000 persons feedback. You take only feedback from 1,000 customers and you can estimate overall satisfaction. That is sampling, means taking a small portion of the data to understand the whole data set. Okay. So there are some types of sampling methods like simple random sampling, then sampling without replacement, or stratified sampling. These are some random sampling technique. Okay. Simple random sampling means every item has an equal chance of being selected. Okay, so you have 100 students and randomly selects 10 for a quiz. So this is like picking them from picking a cheese from a box. It is purely on luck. It is random sampling. This randomly you selected any 10 students from a 100 student group. And sampling without replacement. Sampling without replacement means once an item is selected, it's not put back in the pool. Okay. If one is, sorry, if one sampling without replacement means if one item is selected, it's not put back in the pool. Example, you pick a name for a prize draw. The students can't win again. If his name does not came or he wins one, that if the next time his name won't came. Okay, so sampling without replacement. And sampling with replacement, maybe the item goes back in the pool. It could be picked again and again. Okay, sampling with replacement means it could be picked again and again, and sampling without replacement means it only picked once. And then stratified sampling. Stratified sampling means the data is divided into groups, some strata, and samples are taken from each group proportionally. Okay. Stratified sampling means the data is divided into some groups and our samples are taken from each group. Okay. So this ensures all groups are fairly represented. Okay. So like this is when stratified sampling is useful when the data is skewed. Okay. So what is sampling? Sampling is like testing a bit of the whole these. It saves times, it is easier to analyze and still gives a good idea about the full data set. Okay. Yes, these are types of sampling. I have already said simple random sampling, sampling without replacement, sample replacement, and stratified sampling. Okay. So now we came to aggregation. Aggregation means combining values into one, combining two or more attributes into a single attribute. Okay. So, if you want to know how much you spent this month on snacks, okay, let's say you want to know how much how much you spent this month on snacks, but your data is in daily format, like 30 rupees on Monday, 50 rupees on Tuesday, then again 30 on Wednesday. So now what? You will simply add up all the daily values and get the monthly total, right? So this is called aggregation, combining values into one. So it is the process of combining two or more values or attributes into one in order to summarize or simplify the data. Okay, so what is aggregation? Aggregation is the process of combining two or more values or attributes into one in order to summarize or simplify the data. To purpose, why do we use aggregation? Why we need aggregation? We need aggregation to data reduction, to reduce the number of rows or columns, or to reduce the number of attributes or objects, to summarize the data for easy analysis, or to make data more stable and less variable, to view higher level trends. Okay, to stable data, to make the data more stable, to summarize the data for easy analysis, and to reduce the number of rows and columns. Okay, so if we take an example like daily to monthly sale. Okay, so let's we have Monday 100 sales, then Tuesday 200, then Wednesday 300, and then goes on. So after aggregation, we will total all the sale. Yes, Monday, Tuesday, and for January, then February, then March, and then we will combine all the monthly sale till July, and we will get 20,000 sales. Okay, so this gives us a simplified view instead of handling 30 rows. 30 rows, so this will give us a simplified rows. So, or one more example is like student grades. Okay, so you have marks in physics, chemistry, and maths. So so now we will create a new column like total marks. So we are aggregating all the marks and getting a new value, that is total marks. Okay, so these are aggregations, combining multiple values into one. Okay. So one more question is, why aggregation is important? Why aggregation is important? Aggregation is important because it helps reduce data size. That means simplification, or it makes data easier to visualize, or helps in data mining or business reports, or useful for dashboard or summaries. Okay, so it means what? Aggregation means, saying again and again, aggregation means combining multiple values into a single, more meaningful values to summarize, simplify, or analyze more efficiently. Okay, so I'm going to the next part, that is discretization. Discretization means converting continuous value into categorical value. Okay. So we have three types of attribute, like nominal attribute, ordinal attribute, and continuous. So discretization divide the range of a continuous attribute into intervals because some data mining algorithms only accept categorical attributes. Okay. There are some techniques like binding method I have already discussed, that is equal width, equal frequency, or entropy based methods, etc. So discretization is the process of converting continuous data like numbers into categories or intervals like labels or group. What is discretization? Discretization is the process of converting continuous data into categories or intervals. Okay, so why do we use discretization? Why we use discretization? We use discretization because some machine learning models work only with categorical data. Some machine learning models work with only categorical data or makes data easier to understand, or it helps in classification and reduce complexity. Okay. For example, in grading system, like we are we are combining marks 90 to 100 into group grade A, or 75 to 89 in group B, and 60 to 70 is in group C, and then less than 60 is our fail. So here we turned a number into a category. That is, we turned a number value, the marks, into a category, that is grade. Okay, so discretization is means uh, dividing. Discretization means what? Process of converting continuous data into categories. Okay, the techniques are binding methods. Divide the where we divide the range of values into bins or intervals, or entropy based methods. Entropy-based methods, this use decision tree or information gain to decide where to split the value. And this decision tree information gain, this will you will learn in your fifth or sixth semester maybe. Okay, so these are some higher level algorithm. Don't need to teach and learn it now. It is not much important. We just know what is discretization. We are just learning the basic machine learning. Okay, so okay, discretization, what I say, discretization is putting new raw numbers into buckets or labels to make data more manageable and meaningful, especially for analysis and classification. Okay, so the next time if you turn someone's weight like 73 kg, 74 kg, so into a categories like what? Healthy, unhealthy, overweight, underweight. These are what? Discretization. Okay. So now we are coming to the end of our part. So what we learned today, we learned the data quality, accuracy, completeness, consistency, timeliness, believability, then data cleaning, that is missing or noisy values, then data integrations, data reductions, data transformations. Okay. So these are three assignment questions. Please note it down. These three are assignment questions. Please students note it down. You have to do it maybe in the next assessment session. So please note it down. Okay. So I'm ending my this session here. Okay.
So guys, we will be taking a break and we will be resumed by 11:40. For a time, you can take a short break.
Okay. Am I audible? Hello?
Yes, ma'am.
Hello? Am I
Yes,
audible?
ma'am. Yes, ma'am.
Okay. Thank you. So now let's move to the practical part. Um, so here you can use any platform you are comfortable with, like Jupyter, Anaconda, VS Code, PyCharm. But I am using Google Colab. So if you want to open Google Colab, then open Google Chrome and then search in the search bar. You can type Google Colab and then just click on the first link you see. Okay. After then you will ask you to sign in, and then once you are logged in, you will see recent notebook and options like new notebook. Then click on new notebook and a fresh notebook will open for you. Okay. So here I am going to show you a small data set with some missing and noisy data, where detect and fill missing value, remove duplicates, handle noisy data. These things are we will do here. So first I will explain the code to you line by line, so you understand what it does and why we use it. Then I will give you few minutes to type the same code in your own notebook or Google Colab and run it yourself. Okay? And after that, I will move to the next part and explain the next concept. Okay? So first, this is the code. Create a sample data set with missing, noisy, and duplicate data. Uh, Here we are creating a data set with missing values, noisy, and duplicate value. Okay. So in the first line, you will see import pandas as PD. Okay. So a panda, it is a very powerful Python library used to handle data tables. It's like Excel sheet for Python. It is an Panda is an open source Python library used for data manipulation and analysis, cleaning. It allows you to handle structured data like tables using Python. Okay, so it is like your personal data assistant. It helps you in cleaning and shaping and exploring your data. So this is the we are importing pandas as PD. Okay, so here this says we are creating a Python dictionary as data. Okay, this is a Python dictionary that simulates a real messy data set. Here some names are there: Alice, Bob, Charlie, Bob, then none. It is a missing name. Okay. So age, where 25, none, it is also a missing value. 23, none, it is also a missing value. Then 21. And marks are like 85, 92, minus 75, that is a noisy data. 92, 88. Okay. So maybe you are thinking like, what is a dictionary? Okay, I have already said that we are creating a Python dictionary as data. So, in dictionary in Python, a dictionary is a collection of key value pairs. Okay, key value pairs. In our example, keys are name, age, and marks. Okay, so each key point to a list of values like names, ages, and marks of the student. So this is a dictionary with 3 keys. Okay, now maybe you are thinking, what does data mean here? This data. So data is just a variable name. Here we have gave to our dictionary. Okay, data is just a variable name we have given to our dictionary. think the dictionary is the object and the variable data is the label or name you use to refer to it. Okay. So clear? So data is a variable and it contains dictionary. Okay. So we can say data is a dictionary or data refers to a dictionary. So now coming to the this line df equal to pd dot data frame data print df. Okay, so here we are converting that dictionary into a data frame df. Okay, which is basically a table and printing it out to see what we have created. Okay, in Python we usually store data set in a pandas data frame. Now df becomes your data set. Now it becomes our data set. Okay. Let's once again I clear up the confusion between data, data set, and dictionary. Okay, so what is data? Data is a raw fact, number, word, or value. Okay, and for example, in like name Alice, Bob, this is our data. Okay, and the whole collection of these three keys is a dictionary, which we have given to a name what data, and this data frame df is a the full it is full the data set. Okay, the whole data set. So okay, so this is the dictionary containing the all list of data, which becomes a small data set when we pass into the data frame. Okay. So now this PD, the data frame, it is a function. It is a function in the pandas library that creates a data table. So PD dot data frame data is what? It is a function in the pandas library that creates a data table like an Excel sheet. Okay. So a data frame is pandas way of representing a data set. So data frame is pandas way of representing data set. Okay, it has rows and columns, and you can perform all kind of data operation on it. And if I run it, then wait, it will be the output. Okay, I have already run it before. Yeah, okay, this is the output where name is Alice, where Alice age is 25, marks is 85, Bob age is missing, none value, marks is 92. Charlie age is 23, marks is minus 75, which is a noisy data. Bob age is missing value, marks is 92. And here the row number 4, name is missing none. It is also a missing value. So age is 21 and marks is 88. Okay. So please now note it down and run it by yourself. Okay. I'm giving you a few times.
Ma'am,
Hello.
why there's no comma after 88?
Where?
After 88 in marks.
In marks, okay, it's ending now. That's why.
Oh,
We
okay.
don't need it. Yeah. Okay, done.
Yes, ma'am.
Okay. So we are going to the next part. The next one is fill missing value with mean. Okay, that is a cleaning part. Now we will fill the missing age Now first we will fill up the missing age value. Okay. So let's fix the missing age value in row number 1 and 1 and 3. You have seen it is none value. So what we are doing here, we are calculating average. We are calculating average of the other students. We are calculating average of the other students. Like we will take 80, 85, 92, 92 and 88. Okay, we will take the average of this value. So and we will filling this missing value, one with this average. So here DFH, okay, so it means go. It means DFH means go to the column age in the data frame. Okay, DFH it means go to the it is like pointing at the age column in your Excel sheet. Okay, and then that this is dot fill NADFH and then mean. It means fill NA and within bracket these things DFH means, it means fill all the non missing value in this column with the given value. What is that value? The value is average. Calculate the average form of all the non missing value. Okay, calculate the average of all the average of all these 25, 23 and 21. Okay, so by taking the average, calculating the average, we are getting what? 23. So here we got Bob age is 23 and 23. Okay, so first we have cleared this missing age value. Okay, so please note it down. So here all the missing ages are gone. Okay, so replace it with the average value of 25, 23 and 21. So next we will go to remove duplicate records. So duplicate records are what? Here in our first data set, duplicates are Bob and Bob's is duplicate value, like 2 times it is here with the same age and same marks. So it has duplicate value. So we will remove now duplicate records. Okay. So to remove duplicate records, df dot equal to df dot drop duplicates. Here we are removing the duplicate rows. You see Bob appears twice. Bob appears twice with the same marks and same ages. Okay, so that's a duplicate. So why we are removing this duplicate records? Because duplicate data can mess up our analysis. Okay, like counting the same student twice. So we will remove it. So for that, df, this is a variable name. Df, this is a variable name of our data frame. And dot drop operator. Okay, this is dot drop duplicates. It is an operator. This is used to access a function or method inside an object. Okay, this dot drop operator is used to access a function or method inside an object. Okay, so that means here we are telling our Python code that I want to use a method from the data frame. So which method? Drop duplicates. Okay. So this is a drop duplicate is a pandas method that removes duplicate rows from your data frame. Okay. Understood? What I'm saying is that df is a variable name of our data frame, and the dot drop it is an operator to access a function or method inside an object. Here dot drop access, we are saying our Python code that I want to use a method from the df data frame. Okay, from the df data frame, and the method is drop duplicates. Drop duplicates. This is drop duplicates is a pandas method that removes duplicate rows from our data frame. Okay. What drop means? Drop means remove or delete. Okay, and duplicates means refers to rows that are exactly the same as others. Okay. So if a student entire row is entered twice by mistake, same name, age, or marks, this function removes the repeated one. Okay? Okay, understood?
Yes, ma'am.
Yes, ma'am.
Okay, note it down and run it by yourself. Okay? Then I will go to the next part. Sorry. Now, in our output, here we can see that the duplicate Bob row is gone. It is now clean. Now, to handle noisy data, okay. Handle noisy data means we have the noisy value, that is minus 75. Replace negative marks with average or positive marks. Okay. Now, what we can do? We have this line df marks. This you can see here. Now we will fix noisy data. That one student with minus 75 marks. That's clearly an error. Okay. So here we will go through the mark column, and then if the value is positive, here we are checking if the value is positive, we will keep it, or if the value is negative, then it replaces with the average of all positive marks. Okay. So what is noisy data? Can anyone say what is noisy data?
Ma'am, incorrect data.
What? Hello?
Incorrect
Yes, please
data.
say.
Incorrect data.
Okay. Okay, good. So noisy data is that data that is incorrect, inconsistent, or just does not make any sense. Okay. So in this code, df marks it selects the marks column from our data set. df, that means we are telling our pandas that I want to work on this column. I want to work with this marks column. So now dot apply. Again, I'm saying dot apply is a pandas method used to apply a function to each individual value in the column. Okay. So if the marks column has 5 rows, then dot apply will run your function on each of the 5 marks. Okay, one by one. What it means? Dot apply. It is a pandas method used to apply a function to each individual value in the column. So if the marks column has 5 rows, and dot apply will be run your function on each of the 5 marks one by one. Okay, here you can see one more word is here, lambda. It is an anonymous function. Okay, lambda, it means for each value x in the column, each value x in the column, you can think of x as a box that holds the current mark. Okay, x holds the current mark. We are checking. If x is greater than or equal to 0, then this it is a conditional operator. Okay, greater than or equal to, this is a conditional operator. If x is greater than or equal to 0, then it it will keep it as it is. Else, if it is negative or it is else it is negative, then replace it with something better. In this case, the mean of positive marks. Okay. But if x is greater than 0, it is a conditional expression. X greater than equal to, these are conditional operator. You know, if x is greater than 0, then it keep it as it is, and if it is less than 0, then replace it with something else. In here, we will use mean of positive marks, mean of 85, 92, and 88, and then after getting the average value, we will replace it with the average value. Okay. Uh, so yeah, if DF marks is if DF marks is greater than 0, it creates Boolean marks, selecting only rows where marks are positive. Okay. Or if it and then the dot mean, this is dot mean, it is a calculate the average positive marks. So if some students have 85, 92, 88, then this part will calculate the average of 85, 92, and 88. Okay. The full logic is, that if for every mark x in the column, if it is a positive value, keep it. Or if it is negative, then replace it with the mean of all positive marks. What I am saying is, if every mark in the column, if it is a positive value, then keep it. Or if it is negative, then replace it with the mean of all positive marks. Okay. Now here it is the output. We can see that marks of Charlie, that was earlier minus 75, and now it becomes 88. The average of 85, 92, and 88. So here we can we handle our noisy data. Okay. So now please note it in your notebook and run it yourself. Okay, then. So we are going to the next part, detect missing names. Okay. This is, you can see that row number 4, your name is none. So it is a missing name. So now we have to detect it and replace it with something else. So we are, what we are doing is here, we are doing print df name, then dot is null. Df name means selects the name column from your data frame, and then dot is null. This is a pandas function that checks if a value is missing. What dot is null is a function that checks if a value is missing. Okay, it returns true. It returns true if the value is missing, if the value is none. Okay, we can see this row number 0, 1 and true, here the output is false because here there is no missing value. But in row number 4 it is true. That means there is something that is missing. Okay. What does the okay now okay this dot is null function replaces missing value. Okay, I'm again saying the dot is null function replaces any missing value in the column with an constant level like unknown. Okay, with a constant level unknown. So here we are again print the df functions, df name, the field dot na. Okay, here field dot na is also it is a function which will fill the missing value with unknown. So in the output we can see that this is the non missing name is converted to unknown and the age is 21, marks is 88. The others are same. Just name is replaced with none to unknown. Okay. So please note it down also. And then we will go to the normalization part. Okay. So now next is normalization. Is it done? Detect missing names?
Yes, ma'am.
Okay. So normalization. Here, what is normalization? Anyone? What is normalization? Okay. See, normalization. Normalization means scaling all the numeric values into a common range, usually between 0 and 1. Okay, normalization means scaling all the numeric value into a common range between 0 and 1. So, why do we need normalization? So, we need normalization because when numbers are on very different scales, like salary versus age, the salary numbers are very large and age numbers is very small. So, the model might give too much importance to bigger value. Okay, so normalization fix that issue. So what is normalization? Normalization means scaling all the numeric value into a common range between 0 and 1. Normalization means scaling all the numeric value into a common range between 0 and 1. And we need normalization because when numbers are on very different scales, the model might give too much of importance to the bigger value. So we need normalization to fix this issue. Okay. So now here we are using min max scaling for normalization. Here you can see from sklearn dot pre-processing import min max scaler. Okay. We are importing a tool called minmax scaler from the sklearn pre-processing module. Okay. So minmax scaler is a function. Minmax scaler is a function that will scale our data value between 0 and 1. Why scaling? I'm already saying it that scaling is important because when features like age, salary, marks have different ranges, the machine learning models may give more importance to the bigger number. So we need scaling. Here we are importing a function min max scalar that will scale our data between 0 and 1. Okay. Now, scalar equal to min max scalar, then df marks norm scalar dot fit transform df marks. So here we are creating a min max scalar object, applying it to the marks column. Okay, it creates a new column called marks norm. It creates a new column. This is a new column, marks norm, that contains the scaled version. This marks norm will contain the normalized version of marks. Okay, it contains scaled version between 0, that means between 0 and 1. Okay, so df marks, selecting the marks column from our data frame that please remember this double brackets are used to keep it as a data frame. Okay, these double brackets are used to keep it as a data frame, not a series. Okay, it is a data frame. So scalar dot fit transform. It does two things. First, fit it will calculate the minimum and maximum of the mark column. Okay, in dot fit will calculate the minimum or maximum of the marks column, and then transform will apply the normalization formula. This transform will apply the normalization formula. Okay, so the min max formula was like x will be the value which you can want to normalize. So x minus mean divided by max minus mean. Okay, that was our min max formula. So, and the result is saved into a new column, that is marks norm, meaning normalized mark. Here we can see this is the marks norm output. 85 marks is normalized into 0.00. 92 point marks is normalized to 1.0. 88.33 marks is normalized to 0.4761, and 88.00 marks is normalized to 0.42. Okay. Once again, I am saying here min max scalar. What is min max scalar? It is a function that will scale our data value. Min max scalar is a function that will scale our data value between 0 to 1. Okay. And then df marks scalar equal to min max scalar, df marks norm, these two lines. So creating a min-max scalar object and applying it to a marks column. Okay, applying it to a marks column, it creates a new column that is marks norm, which will contain the scaled version of marks. Okay, scaled version of marks. And df marks, selecting the marks column from the data frame, and double brackets means it is the whole is as a data frame. It is kept to as a data frame. Okay. So you are using min max formula and we are normalizing the marks value. So understood?
Yes, ma'am.
Okay, note it down and run it, please. Okay, done. So now we are going to the discretization part. Discretization. What is discretization? Please say what is discretization? What is discretization? Can anybody say?
And it means to categorize something.
Okay. Okay. Discretization means converting continuous numbers into categories. Okay, we're right. Means converting continuous numbers into categories. Okay. Discretization means what? Discretization means it is a process of converting continuous number into categories. Thus, likes marks are turned into grades. Okay. So here, okay. We have beans. These are beans. Means group. You are defining the cutoff ranges. Cutoff ranges. You can say beans here. These are cutoff ranges. Okay, for our categories. So marks, it means marks from 0 to 60 in first bin, then 60 to 75 means second bins, and 75 to 90 means third, or 90 to 100 means in fourth bin. Okay. So, and these bins are like buckets. We are putting each student's marks into into the correct bucket. Okay. We are putting each student's mark into the correct bucket. Now here levels are like fail, average, good, and excellent. Okay. Now we are giving names to levels. We are giving labels or names to each bin. Like 0 to 60 means fail, 60 to 70 means average, 75 to 90 we are giving good, and 90 to 100 we are giving them to excellent. Okay, so these are categories, or what we call these are categories or ordinal levels. Okay, so why ordinal levels? Because they have order: fail, average, good, excellent. These are order. So these are ordinal. We can also say these are ordinal levels. Okay, now this is DF grade equal to PD dot cut DF marks beans equal to beans, labels equal to labels. So what does it this lines means? DF marks and second is DF marks and grade. Okay. So okay. Now this is DF marks. It refers to the marks column. I have already said many times. DF marks, it means refers to that column. Here marks is, so DF marks means it refers to the marks column. Then PD dot cut, this function PD dot cut, this function cuts the data into bins. Okay, cuts the data into bins, different groups. Cuts the PD dot cut, it will cut off the data into bins. Then it comes to bins equal to bins. It uses the cutoff ranges we defined. Cutoff ranges we defined. It will use these ranges here. And labels equal to labels. Apply all these labels to these bins. Okay. So the result is a new column in the dataset called grade. which has values like good, average, fail, or excellent. Okay. So here, print DF marks grade. Print DF marks grade. It means what? It now is just print our two columns, marks and column. Okay. Print DF marks means it will just print these two columns, marks and grade, the original marks and the grade that is will newly assigned grade value. Okay, so here this is the result 85, that is good. 85, 75 to 90 we are labeling as good, so these marks are converting as grade good. Then 92 is excellent, 88.33 is converting to good grade, and 88.00 is converting to good grade. Okay, clear? Please note it down and run it. Check is it okay or not. If anyone have any doubt, can ask me. Okay, now move to the aggregation part. Aggregation. Can anyone say what was aggregation mean? What is aggregation?
I'm collecting and summarizing data from multiple rows and columns into a single result.
Okay. Okay, good. So aggregation is when we combine or summarize data. For example, by total, average, or count. Okay, aggregation means combining data into a single one. Aggregation means what? Combining data into a single one. So here we are, we have a new small data set, which it is another data set. A small group data set with two columns like city and sale. Okay, city and sale. Here we are creating okay, we are creating another data set, that is city and sale. This df group equal to pd dot print. Okay, so we are created city where in city we have values or we have cities like Delhi, 2 times Delhi and 2 times Mumbai. Okay, and sales are 1,000, 1,500, 2,000 and 2,500, 2,500. Okay. So now we will grouping the data by city and adding up to the sales for each group. Okay. So here what we are doing, this the aggregate the total sales. It's our sales by for Delhi 1,000 and for Delhi this is for also 1,500 and Mumbai it is 2,000 and 2,500. So we are aggregating total sales by city. So in here, sorry. Print df group dot group by city sum. Okay, here what we will do, we are sum up the values within each group. Here we will sum up this value. Okay, sales column. For Delhi, we will sum up like 1,000 and 1,500, and for Mumbai, we will sum up like 2,000 plus 2,500, and this group by dot city. Here also this group data based on the value. So here in group 1, we created two group, group 1 Delhi and group 2 Mumbai, and we dot sum. By this dot sum function, we sum up the values within each group. Here some sales column from all. So for Delhi it will be 2,500, and for Mumbai it is 4,500. So this is our final output for Delhi. It is 2,500, and for Mumbai it is 4,400. This is our aggregated table. Okay. First we have four rows like Delhi, 2 times Delhi, 2 times Mumbai. Sales was like 1,000, 1,500, 2,000, 2,500. So now we aggregated all this and make only two rows, two columns where Delhi is 2,500, the total sum of sale, and Mumbai is 4,500. Okay, this is our aggregated table which shows the total sales per city. Okay, so here df dot groups equal to pd dot data. It creates the table with I already have said that it creates the table with sample data. It df dot group equal to pd dot data frame. It created a table with sample data. Then group by city. Group by city, it groups rows based on unique values in city. Okay, city. And then dot sum, it is a function. It sum of sales value for each group. And last, it prints the output, or it display the output. Okay. So please note it down and run it by yourself. We are now ending this session here. So this was the last example aggregation. So note it down and run it by yourselves. So these are very basic, small important steps that you will use in almost every data science or machine learning project in the future. So please practice well and revise the steps and explore more. Okay, and if you have any doubt, you can ask me. Okay, so now I'm ending this
Okay,
session here.
thank you,
Thank
Rakhi.
you.
So I hope there's no question from. Okay, we have a chat. Okay, so everything is clear. So there is a small note for everyone. That tomorrow you have two sessions like for assessment and assignment. So Ria will help you out to accomplish those tasks. So kindly join tomorrow at 10 a.m. All right. For now, you can leave the meeting. Thank you.